So in this video lecture, we have to start with the third type of colloid, that is associated colloids. So in associated colloids, there are some substances which at low concentrations they behave as normal, strong electrolyte, but at higher concentrations they exhibit colloidal behavior due to the formation of aggregates. You must have studied in your junior classes about micelles. So suppose this is sodium stearate C17H35 CO negative Na plus. So if I can draw it as like this. This is COO minus, right? So this is this is hydrocarbon chain, or we can call it non-polar tail, and this is a polar end, so we can call it polar head. Now if we have only if these electrolytes only, if we have these substances only in small concentrations, so they will act as they will just normally act as how they will act. They will act as strong electrolyte. For example, if I add them in water, what will happen? If I simply add them in water, what will happen? We know that water is polar in nature, so the polar head will be inside the water and non-polar tail will be outside the water. Yes, right? Now this will happen only at low concentration, but as we increase the concentration, micelle formation will take place. Let's see the next slide. The formation of micelle takes place only above a particular temperature, that is Kraft temperature, and the formation of micelle also takes place only above a particular concentration, that is CMC, critical micelle concentration, and whose value is 10 to the power minus 4 to 10 to the power 3 mole per liter. This is the CMC value of a soap or detergent. Now just read this thing, like on dilution, these colloids revert back to the individual ions. Means as soon as we increase the concentration, they will form associated colloids or micelle. But on dilution, if we add a large amount of water into it, what will happen? They will revert back to the individual ions. Now next is the preparation. So before starting with the preparation, I would like to tell you about the micelles, how micelles are formed. See what happens when the concentration increases, they will form a circle, just a circle around, a circle in water. Suppose this is water, right? And we know that water is polar in nature, so the polar end will be towards water, and inside it has non-polar end. And this is nothing but this is micelle. And on this basis also, this basis micelle, the cleansing action of soap takes place. How the cleansing action of soap takes place is, suppose if we add the soap or detergent inside water, what will happen? Because we know that oil is also non-polar, so oil will come into contact with this hydrocarbon chain, and when we will rub the cloth, what will happen? This hydrocarbon chain will exert pressure on this oil droplet, and hence we get a clean cloth. So next topic is preparation of colloidal salts. Now how colloidal salts are prepared? The first method is electrodisintegration or Bragdon's arc method. Now what is this method? In this method, what happens is we have an ice bath, we have a dispersion medium and stabilizer. We actually use an electrolyte to stabilize it. Now what happens here is, so this is electrolyte. Suppose this is a rod of gold, right? Suppose this is a rod of gold, A. Now what happens as we heat this? What happens as you pass electricity? This Au gold will firstly convert into vapors. They will convert into vapors, and they will convert, and we have used ice bars to condense it, to further condense this, so that we get back our Au soul. So what is happening in this case is that this method involves dispersion as well as condensation, right, side by side. And generally this method is used for like metals like gold, silver, platinum, etc., right? And this electric arc, yes, this is called as electric arc, is stuck between the electrodes of the metal immersed in dispersion medium. The intense heat, we are actually providing intense heat which will convert this gold into vapors, and this ice bath is actually used to condense the vapors formed into particuloidal soul. I hope this much is clear to you. We are actually using stabilizer. Why we are using stabilizer? Because we are using stabilizer because suppose I am adding an electrolyte. Suppose I am adding KOH, just or an electrolyte, NaCl or any electrolyte. Now what happens here is, when these vapors, they will mix together, aggregate together to form a colloid. What happens? Suppose we get a Au colloid. Now this electrolyte will actually disperse a negative charge on its surface, and another atom also, so that they do not mix together. To form a PPT, precipitate, right? So that is why we use this method. I hope this much is clear to you, right? Now next we have is chemical decomposition method. In this chemical decomposition method, or you can say chemical method, we have 4 types of chemical methods that we have to study. First method is double decomposition. So what happens in this method is that, suppose we have arsenic oxide As2O3. It reacts with hydrogen sulfide, and we will get arsenic sulfide as a sol plus water. So this is double decomposition. Next we have reduction. Suppose we have gold twice of AuCl3. Suppose the oxidation state of Au here is +3. It reacts with thrice of HCHO plus water, that is formaldehyde. Thrice of HCHO plus water. It will get reduced and it will form twice of Au, and the oxidation state of Au is 0, plus Au sol, plus now the reduction of Au sol has taken place, so this HCHO will get oxidized to HCOOH plus 6HCl. Then we have third method which we have to study is oxidation. What happens in oxidation is that SO2 plus H2S, they will react twice of H2S. They will react to form sulfur sol, that is 3 sulfur plus water, right? Last we have decomposition method. Last we have hydrolysis. Last method we have hydrolysis. Now what happens here is, suppose we have iron chloride, it reacts with water and the hydrolysis takes place and will get iron oxide, that is FeOH whole twice plus HCl. We'll get a sol of FeOH whole twice plus thrice of HCl. So these are the methods by which we can prepare our sols. The last method that we have to study here is peptization. Now what is peptization? See, peptization means, what happens is, it may be defined as a process of converting a precipitate into colloidal sol by simply shaking it with the help of a stabilizing agent. What are we doing here is, suppose peptization, basically it's a method of converting precipitate. Peptization, just simply look, it is a method of converting precipitate into, is a method of converting precipitate into a colloidal soil, into a sol by shaking. How? By shaking plus adding very small amount of electrolyte. Yes, basically what happens, the ions of the electrolytes gets absorbed on the surface of the sol, so that further coagulation does not take place or further precipitation does not take place. Like suppose how it happens, suppose just now I have told you we have prepared a sol of FeOH whole thrice. Now what happens? This FeOH whole thrice sol. Yes, we have just prepared a sol of FeOH whole thrice. Now suppose if I am adding electrolyte, if I am adding any electrolyte into it, now what happens? This electrolyte will either the sol will either absorb positive charge on its surface, the sol particles, or negative charge, which will actually prevent further coagulation, right? Because now these two they both have positive charge on the surface. Now repulsion will take place and they will never come together and they will never get precipitated. Yes, I hope this much is clear to you. So basically this method is actually used to convert freshly prepared precipitate into the sol. It's very famous for converting freshly prepared precipitate into sol by shaking and adding small amount of electrolytes. I hope this is clear to you. Now next we have purification methods of colloidal solutions. Now what are the purification methods of colloidal solutions? The first method is dialysis. Now what happens in dialysis? See, can you see the sol particles, right? And we know that inside the sol particles some crystalloids are also present, means some electrolytes are also present. So we are adding water into it, and with the help of this dialyzing membrane, what happens? This water and crystalloid, they will get out. It will start removing. So we will get rid of the excess of crystalloid present in our sol. Yes. So basically, this process is based on the phenomena of diffusion, right? Why? Because we are using the why? Because you are using dialyzing membrane, and with the help of this dialyzing membrane, all the soluble impurities will get removed from this solution, right? For example, we can use the dialyzing membrane or parchment paper. For example, yes. For example, sometimes artificial kidney is used in the body of the patients to purify blood, so that artificially, and we call it dialysis. So that phenomena, that purifying of blood is actually based on this phenomena. Yes, that is why we call it dialysis. Next we have is electrodialysis. Now, what is this electrodialysis? Now, actually, this dialysis process is very slow in nature. It takes a long time. So we have this electrodialysis process. That is, we use this process in the presence of electricity. Now, what happens? We know that we have soul particles as well as we have crystalloid present in the crystalloid present in the soul particles. So now we are actually, what are we doing is, we are applying an electric field, and if the so what happens, the electro because we are actually we were because see, now we were adding electrolytes, right, for the precipitation of our souls. So we know that some amount of electrolytes are also present in our soul. So by using this electrodes, that is anode and cathode, we will get the electrolytes, the excess of electrolytes will be removed from our soul, and we will get pure soul back. So electrolyte, positive charge and negative charges, both the charges are present. So the negative charge will move towards the anode and the positive charge will move towards the cathode, and in the end we'll have our pure soul. Now next is ultrafiltration. Now this ultrafiltration is a process of purifying where we use ultra thick, like ultra thin paper, means like which does not allow, it's basically it is for the particles whose size are too large. It will not allow those particles to move through it. So this is ultrafiltration is a slow process. So to speed up this process, we generally use pressure or suction pump so that this process gets faster, right? I hope this is clear to you. Ultrafiltration, in ultrafiltration, what we have to do is we just have to simply use a ultra thick film. Like we have one normal filter paper and we have an ultra thick filter paper, which does not allow the movement of any kind of particles. Yes, the movement is restricted of the particles. Now next we have properties of colloids. Now optical properties. First we have to discuss about the optical properties of colloids. See, this is light source, this is two solution, colloid and suspension. You must have studied about Tyndall effect in class, in your junior classes also. Now what is Tyndall effect? See, in two solution we know that when we try to pass light through two solution, now we will never see any kind of white light through them. But through colloid and suspension, white light will be visible. It means, yes, the size of the two solution is very small, but that of colloid and suspension are larger. That is why they are allowing white light to pass through them. For example, cinema hall, the phenomena behind cinema hall, that projection is based on Tyndall effect. Next we have Tyndall effect. See, light source, Tyndall cone, and in suspensions, what happens? This is a colloidal solution and will observe scattering of light. Tyndall effect is observed only when the following conditions are satisfied. First is the diameter of the dispersed particles. The diameter of the dispersed particles must be smaller than the wavelength of the lights used. Means actually the wavelength of the light, lambda, yes, and the particles, the diameter of the particles, of the dispersed phase particles. The diameter should be less, is not much smaller. It should not be much smaller, otherwise scattering will not be possible. This lambda and the diameter should be equivalent. Otherwise, what will happen? The scattering will not be possible. Right? Second is the refractive indices of the dispersed phase and dispersion medium should differ in greater in magnitude. Yes, because why? If they'll have same refractive index, then what will happen? If two substances they are same refractive index, what will happen? The line actually it passes in a straight line. And if there is a large difference in the refractive index, then what happens? Then only scattering takes place. Yes, this is concept of optics. Concept of optics you have to apply. Yes, refraction. Refraction will only take place when there is a large difference in the refractive indices value of dispersed phase and dispersion medium. Now next we have Brownian motion. You must have studied about Brownian motion in your junior classes also. That what happens, colloidal particles. The particles they will not remain as it is, they'll keep on moving. Can you see the movement of these particles? Yes, so we can say they will keep on moving in this zigzag motion, and this motion is actually independent of the nature of the particles but depends on the size. This motion is independent of nature of particles, like what particles you are taking, of nature of particles. Independent of nature of particles but depends on the size. But depends on the size of the particles. On the size of the particles and viscosity. Size and viscosity of particles. Tell me, if the size of the particles, viscosity of particles, now you tell me by yourself, smaller the size, if the size of the particles is smaller the size, higher the viscosity, tell me what will be the movement? Smaller the size, higher the viscosity. It means smaller the size, lesser the viscosity, right? Viscosity means lesser the viscosity means stronger the movement, yeah, or more random will be the movement. So smaller the size, lesser the viscosity, more random will be the movement. So these two factors are important. Yes, smaller the size and lesser the viscosity for Brownian motion, and these two factors are important for Tyndall effect. Yes, and I hope this video is clear to you.